Okay, let's get started. So, this is going to be kind of short because I don't want to get too far ahead of Mr. Merzinski, but he has started in on exponential functions, and I want to do that as well. I want to make sure that we get a little bit of practice before we see it again in his class. Also, I sent out grades yesterday, and hopefully everybody got those and was looking at them and whatnot. Again, if you have any questions about your grade, just let me know. So, let's get on into exponential functions. So, exponential functions, as we're about to see, there's many different types of functions. What we've been looking at mostly are linear functions. However, exponential functions are a little bit different. So, with exponential functions, we might have something like f of x equals, and I'll give us something simple, 2 to the x. Okay, so here in this function, our x is in the exponent slot. So as we change x, that exponent is going to change as well. And if you are familiar with exponents, which you should be by now, you know that exponents can rapidly change something. So let's go ahead and take a look at what the graph of this is going to look like. So I'll go ahead and make a t-chart real quick. Remember that a t-chart compares the variables that we have. Oh, and it's doing that to me. Okay. All right. So this slot right here is going to be our x's. It's what we're plugging in for x. And this slot right here is our y, or our f of x. It's what we get out when we plug something in for x and then do all of the operations. Okay. So again, we have our x, we have our f of x, or really our y. So let's go ahead and plug some numbers into here. I'm going to use the typical ones that I usually use, which is -2, -1, 0, 1, and 2. Okay. Now, because I'm pretty sure that we're more familiar with positive exponents, I'm going to start with those positive exponents, plugging them in for x. So 0 in for x here. So that would be f of 0 equals 2 to the 0 power. Again, what we're doing here is we're taking each of these values and plugging them in for x. So anywhere that we have an x in this original function, we're going to replace it with 0. Okay, so 2 to the 0 power, well, anything to the 0 power is 1. So f of 0 is going to give us 1. And we'll record that over here in our f of x. So there's a point right there. Okay. 1. Plug 1 in for x. So that would be f of 1 equals 2 to the first power. Anything to the first power is itself, so this will be 2. Okay. Then we have 2, so we plug in 2. So f of 2 equals 2 to the second. 2 to the second power, 2 squared is 4. Okay, so now let's look at these negative values here for x. So remember that when we plug in something negative for this exponent here, a negative exponent doesn't do anything else except for take the reciprocal. And by taking the reciprocal, what we mean is flipping this number. So f of negative 1, this value right here, equals 2 to the negative 1 power. Again, that's going to take the reciprocal of 2. So this is going to flip, and we are going to have f of negative 1 equals, okay, the reciprocal of 2 would be 1 over 2. Again, it flips. So this is 1/2. Okay. So how about negative 2? F of negative 2. So it's still going to take the reciprocal, but now we have power 2 as well. So this will be f negative 2 is 2 to the negative 2. Again, it's going to take the reciprocal, so this will be f of negative 2 equals 1/2 squared and 1/2 squared, that means 1/2 times 1/2. So multiply the tops and multiply the bottoms. 1 times 1 is 1, 2 times 2 is 4. So f of negative 2 equals 1/4. Ugh. There we go. Okay, so now we've got some points we can graph. So let's start with this right here, negative 2 for our x and 1/4 for our f of x or y. So negative 2 is right there, and then 1/4 for our f of x. That goes up 1/4, that's like right there. And I'll just put a little point there. Kind of hard to be careful with it. There we go, there's a little point. Alright, same thing here. Negative 1 for our x and positive 1/2 for our y. So there's negative 1, then there's positive 1/2 is about right there. Okay, so not a whole lot of change, but then all of a sudden we get to 0, 1. So we have our first whole number, then 1, 2, and you might be able to see what's starting to happen here. 2, 4, 2, 4. So as we increase our x, our y is increasing what we call exponentially. And what that means is that it is going up faster and faster and faster and faster and faster with each of these new points. Okay, so the change in y is increasing as we go farther and farther and farther. So let me get a new color for our line. I'll make it red. And bear with me here. I'm going to try to make this line. Whew. Let's make this fidelity a little bit higher. Yeah, that's a little better. Okay, let's try to actually hit the points though. There. So as we can see here, this will continue like this. So this will just shoot up like that. This, however, will keep on going down, 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 down. But will it ever hit 0? So that's a good question for us to think about here. As we go this direction, yeah, it's increasing quite a lot. But as we go this direction, it's decreasing by the same rate. However, it's going, 4 to 2 to 1 to 1/2 to 1/4. The next one would be 1/8. No, 1/16. Right? Let me think about it real quick. Sorry. No, 1/8. And then the next one would be 1/16. And the next one would be just another fraction, but it's just gonna be smaller number. It's not gonna quite get to 0, and that makes sense. There is no number that I can plug in for an exponent to make 2 be 0. If I plug in 0 for that exponent, it just makes this 1. If I plug in a negative number for this exponent, it doesn't matter what it is, it's just going to be one of these numbers flipped as a fraction. So like this one, power 1 gave us 2. Power negative 1 gives us 1/2. Power 2 gives us 4. Power negative 2 gives us 1/4. And so on and so forth like that. So it doesn't matter what we plug in for this number here, we're never going to reach 0. And so we say that that is our range. Okay? So we can plug in any number for x, that doesn't matter. However, our range here is that we can never quite get to 0. So for our range, we would say y must be greater than 0. Not equal to, because again, we can never quite get to 0, but it has to be greater than, not equal to. Okay, so I'll pause for any questions we may have. Okay, I'm not seeing any questions, so I'll move on. Yeah, I'm going to need this, so I'm going to just back up. Okay. So let's try another function. The last one we did was 2 to the x. What if we did like a negative number? What would that do? Okay. So how about f of x equals something like negative 3 to the x? All right, so once again, we are going to want to get a t-chart here so we can look at our values. So x is on this side, f of x is on this side. Again, you can think of that as being y. All right, so same values, negative 2, negative 1, 0, 1, and 2. So let's see what we get here. So let's plug in negative 2. So negative 2 into here, that's f of x equals negative 3, oops, not f of x, f of negative 2, that's what we're plugging in, equals negative 3 to the negative 2. So like we said before, the only thing that this negative on the exponent does is take the reciprocal. It doesn't do anything else. So this is going to be f of negative 2 equals 1 over negative 3. And the whole thing is squared. Okay, so now we square this since we've gotten rid of that negative. So multiply 1 over negative 3 times 1 over negative 3, multiply the tops and bottoms. So 1 times 1 is 1. Negative 3 times negative 3 is 9. Positive 9. So f of negative 2 is positive 1/9. Okay. So let's see about these other values here. Plug negative 1 in. So x is going to be negative 1. That means we have negative 3 to the negative 1. All it does is take the reciprocal. So this is going to be 1 over. Oops. Let's calculate it. I want to make sure we have this down. So negative 3 to the negative 1. Again, what this negative does, is take the reciprocal. So we have negative 3, take the reciprocal of that, that's 1 over negative 3. Okay, so we have a negative then. All right. How about 0? 0 makes it 1. How about 1? Okay, that would make it negative 3. How about 2? That makes it 9. Okay. So what's going on here? What have we done? Let's take a look at our graph then. So negative 2 is positive 1/9. So negative 2 is positive 1/9. That's like right there. Negative 1 is negative 1/3. Right there. 0 is 1. 1 is negative 3. 2 is 9. Well, this doesn't look right at all, does it? So something is wrong here. Okay. So I'm going to give y'all a moment. I'll trace the graph. So, like that. So I'm going to give y'all a moment to try to figure out, does this actually look like what it's supposed to look like? Or has something gone wrong? So I'm going to give y'all a moment to figure that out. Okay, so what have we decided? Have we decided that this looks correct? Or does this look weird? I mean, the last one that we did was just a simple curve. It wasn't doing this weird up and down thing. Okay? Well, I actually have the real graph of this. So, again, do we think it's going to match this graph that we made, or is it going to be kind of weird? let's take a look. And I'm going to hide this real quick. Okay, here's our real graph. Ignore the red one here. That's something else. Just look at the blue part. Okay, so yeah, actually, this looks like our graph. It goes up and down. Why is it that this one is so up and down, though? That's kind of strange. Our other one was just a nice little curve. So let's go back to our other one. Well, it's because of this negative. Remember that if we have a even exponent, something like 2, 4, 6, 8, something like that, something that is an even exponent, it will cancel out that negative. So, for instance, 2 is a even number. It cancels out that negative. We have positive 9. If we have an odd exponent, though, something like 1, 3, 7, anything like that, it's going to not cancel out that negative. And so we have, like, for 1 here, negative 3. So when we have a negative value like this that we're applying this x exponent to, it's going to go up and down. Okay, so watch for that when you're working on Hawks. If you have something that looks like this where we're raising a negative number, it's going to go up and down. And it will actually continue to go up and down. It'll get really, really compressed. It kind of starts wide curves like this and then get really, really compressed and just get thinner and thinner and thinner and thinner and thinner curves. They're really interesting to look at. I like these types of functions. Okay. So let's back up some more. And let's try another function. Okay. What function do we want to try? Let's try a fraction. So f of x equals, let's say, 1/2 to the x. Okay. So f of x equals 1/2 to the x. All right, so let's get another t-chart going so we can organize our points. All right, so x on this side, f of x on this side, and same values, -2, -1, 2, I'm sorry, 0, 1, and 2. Okay, so let's start with -2. Well, again, let's calculate this out step by step. So this would be f of -2 equals 1/2 to the -2. Again, what this negative on our exponent is going to do is it is going to flip our number. It's going to take the reciprocal. So the reciprocal of 1/2 is 2/1, or just 2. So f of -2 equals 2 to the second. Okay, so 2 to the second, we know what that is. That's 4. So f of negative 2 is 4. Okay, what about negative 1? So back this up. In class, we have to worry about cell phones, and in the lecture, we have to worry about Discord. Okay, so negative 1. If we plug that in there, again, this is 1/2 to the negative 1. So take the reciprocal. That's what that negative means. So f of negative 1 equals, well, if we flip this, that's just 2 over 1, or 2. And that's it. So we get 2 here. Okay. 0's easy. Anything to the 0 power is 1. So I'm not even going to bother calculating that one. How about plug in 1? F of 1 equals, let's see, so that's 1/2 to the 1. Well, anything to the first power is itself, so that's 1/2. And by this time, you can probably see where this is going. So let's do 2 in for x. F of 2 equals 1/2 to the second power. Okay, so multiply this by itself then. So 1/2 times 1/2, multiply the tops and multiply the bottoms. So 1 times 1 is 1, 2 times 2 is 4. And that means that f of 2 equals 1/4. So this is the reverse of our original function that we did when we did 2 to the x. Okay, so 2 to the x, we had 1/4. Whoops. Let's make that a 4. When we had 2 to the x, it was 1/4, 1/2, 1, 2, 4. Now that we have 1/2 to the x, it's the opposite. It's 4, 2, 1, 1/2, 1/4. So let's take a look at this graph. So negative 2 is 4. So negative 2, we've got 4 right there. Negative 1 is 2. 0 is 1. 1 is 1/2. 2 is 1/4. So if we think about our original function that we did in the beginning of class today, this is the same function, but it slopes in a different direction. So this fraction here changes the direction that we're going. So instead of exponentially getting bigger and bigger and bigger and bigger and bigger as we go with larger and larger values for x, we're exponentially getting smaller and smaller and smaller and smaller and smaller. What does that mean about our range? Well, same thing. It's still coming down towards this x-axis, but will it ever get to 0? No. It's never quite going to be there at 0. So we have to say that our y must be greater than 0. Okay, so I'll pause for any questions we may have. Okay, I'm not seeing any questions. So, again, what you can expect with exponential functions typically is a curve that either gets smaller and smaller and smaller and smaller and smaller like this, or bigger and bigger and bigger and bigger and bigger. And each point is going to be further from the last point or closer to the last point as we move on. So this is what we call exponential growth and exponential decay. And like I said at the beginning, I want to keep this one short because I don't want to get too far, Mr. Merzinski. So Monday, we will be seeing some real world examples of exponential growth and exponential decay. Because, yeah, there's actually a lot of different examples out there. So, I hope you have a good day. Again, short lecture today. Keep on with your homework. I think there is a homework due today. I think that's 4.2, maybe. I'd have to go back and look at Hawks. But that one is due for Mr. Merzinski. And just make sure you get that turned in. So I will see y'all later, and I hope you have a good day.